Example 30. It says a circular cylinder opened at one end is constructed of a thin sheet of metal whose surface area is 600 pi centimeters square. The height of the cylinder is 8 centimeter and the radius is r centimeter. Show that the volume contained by the cylinder V is pi r over 2 600 minus r square. Is pi r over 2 600 minus r square. Alright, let's have a go at this question. Alright, essentially, this is what we have. There's a cylinder, and the cylinder is opened at one end. So let us say that the top of the cylinder is open and the bottom is closed. It's only opened at one end. So that's my cylinder. The height of the cylinder is h and the radius is r. We're told that the surface area is 600 pi centimeters square. So the surface area would be equal to pH plus A. A alone because pH gives you the area of the sides of the curved surface. A is the area of the flat surface. So this is a flat surface. It's a circle. So this would be 2 pi RH plus A, which is pi r squared. Alright, so pH gives you the area of the curved surface, and A is the area of the flat surface, which is a circle. Now, this we're told is equal to 600 pi. This is equal to 600 pi. So, let's divide the entire thing by pi. Let's divide the entire thing by pi. Alright, and if we do, we'll end up with 2RH plus r squared is equal to 600. Therefore, 2RH is equal to 600 minus r squared. Divide both sides by 2r. We're going to get H is equal to 600 minus r squared over 2r. Alright, now we're to show what? We're to show that the volume contained by the cylinder is equal to that. Now, volume of the cylinder, V, is equal to AH. A cylinder is a solid shape with a uniform cross-section, and the volume of all solid shape with a uniform cross-section is given by the formula V is equal to A times H, where A is the area of the uniform cross-section and H is the height. So this would be pi r squared H. But to the right, we already showed that H is equal to 600 minus r squared over r. So I can replace this as what? Pi r squared, and this is times what? 600 minus r squared over 2r. This r here can cancel one of the r up there, and so what we really should end up with is pi r 600 minus r squared over 2. Alright, so let us see if that's what we're supposed to get. Pi r 600 minus r squared over 2. We're asked to show that the volume is equal to that. That is part A of the question, and we were able to do it. Now, part B of the question asks us to what? Estimate the value, evaluate, the value of V and determine whether this value is a maximum or minimum. Alright, so, well, V is equal to pi over 2, 600 r minus r cubed. Alright, pi over 2 is a constant. That's not going to interfere with anything. So dv by dr is equal to pi over 2 and 600. When you differentiate 600r with respect to r, you're going to get 600 minus 3r squared. Now, at stationary point, where you have maximum or minimum and minimum, dv by dh or dv by dr, dv by dr would be equal to 0. So therefore, pi over 2, 600 minus 3r squared would be equal to 0. Pi over 2 is not 0, therefore 600 minus 3r squared must be equal to 0. So 600 is equal to 3r squared. Divide both sides by 3. We get r squared is equal to 200. And r would be equal to the square root of 200. R is the square root of 200. So therefore, at the turning point, or at the stationary point where maximum or minimum occurs, or where you have maximum or minimum, the radius is equal to the root of 200. Alright, the next thing we want to evaluate is if this is maximum or minimum. Alright, so therefore let us find, let us go back to dv by dh, dv by dr, which we have here, pi over 2, 600 minus 3r squared. So let's go to the next page. So dv by dr, which is pi over 2, 600 minus, is it 3r squared? I think it's 3r squared. So now d2v by dr squared is equal to about pi over 2. That's not changing anything. And inside the bracket you're going to have minus 6r. So this is equal to minus, this goes 3 times 3 pi r. Is equal to minus 3 pi r. This is negative. If it's negative, it means that r is equal to the root of 200 is the radius of the cylinder of maximum volume. Alright, and we're asked to evaluate this volume. V was equal to what? What was V equal to? V I think was equal to, alright, let's go back. We can go back to the questions. At the question, V is equal to pi r over 2, 600 minus r squared. So it's equal to pi r over 2, 600 minus r squared. But r is the root of 200. So this is pi, the root of 200 over 2, 600 minus r squared, which would have been 200. So this is 400 divided by 2 is 200. So the answer is 200 root 200 pi. It's 200 root 200 pi. So let's evaluate that. 200 times the root of 200 times pi, and this comes out to be 8,885.8, and this is centimeters cubed. So the maximum volume of the cylinder is 8,885.8 centimeters cubed.